study about the topic section and midpoint formula. In this chapter, we have been given some certain formulas to calculate the section and midpoint there. But before we start with section and midpoint formula, first we will look at distance formula which we have read in the previous class, but it has been removed from our syllabus. But we will have a look at it. Distance formula. In distance formula, we have been given a formula to calculate distance between two given points. In distance formula, we have been given a formula to find the distance between two given points here. What was the distance formula there? The distance formula was x2 minus x1 whole square plus y2 minus y1 whole square under root. By using this formula, we were calculating the distance between two given points here. So in this formula, what is the variable x2, x1, y2, y1 here? The variables here are used to denote the points. Here we are denoting a point by using coordinates. Since the coordinates are same here, we will give the variable a value x1, y1 and x2, y2 here. We are denoting a point by using coordinates. So what are coordinates here? I will make it clear for you. On a coordinate axis, when we put a point, the position of a point is known by using coordinates. Its length on x-axis and its length on y-axis. And they taken the length on x-axis and the length on y-axis taken together forms coordinate. X is the length on x-axis, y is the length on y-axis. It is also known as abscissa. The length on x-axis is known as abscissa and the length on y-axis is known as ordinate. And abscissa and ordinate taken together form here coordinates here. Okay. Now coming on to our topic, section formula. As distance formula have been removed from our topic, but I have made it clear for you that what was distance formula, what are coordinates here. Now we are coming on to the point section formula. Before knowing about the formula, first we will know about what is section here. So when we are taking a line segment, we can see here that it is in a single part. But if we put a point on this line segment, we can see that this one line segment has been distributed into two parts here. This line segment has been distributed into two parts. And on which note it is distributed into two parts? This point is distributing this line segment into two parts. So this point is creating section here. And for calculating the coordinates of this point, as I have told you, a point is denoted by using coordinates. So for finding the coordinates of this point, we are given a formula, and that formula is known as section formula here. So if we are denoting this point by x1, y1, we are denoting other point by x2, y2, and we are denoting this point by x and y here. So any point is denoted by using coordinates. What is section formula doing here? When a point lies on a line segment and it distributed the line segment into two parts, not equal parts. It is just distributing the line into two parts, and for finding the coordinates of that point, we are using section formula. And if the line here is distributed into two parts, it must have been distributed in some ratio. So we will take it as m1 and m2. Suppose this part is in the ratio m1 and this part is in the ratio m2. Now on the basis of this note, the section formula here is m1 x2 plus m2 x1 by m1 m2, m1 plus m2. And for the second part, m1 y2 plus m2 y1 by m1 plus m2. By using this formula, we are finding the coordinates of the point which is creating a section here, means which is creating a part here. The m1 here, the variable m1 here is the this part in which the line has been getting divided. X2 is this variable, the abscissa of the this point. X1 is the abscissa of first point. M1 and M2 are the ratio here. So on these variables we are using to find the section here. Okay. Now coming on to some examples on the basis of section formula here. So we are using this formula to find the coordinates of this point which is dividing the line segment AB into two parts. Suppose we are letting this point as P. So for finding the coordinates of P, we are using the section formula here. That is, m1 is multiplied by x2. The value of m1 here is 3. The value of x2 here is 3. So m1 multiplied by x2 is 3 multiplied by 3 plus m2 is multiplied by x1. The value of m2 here is 2 and the value of x1 here is minus 4. So m2 multiplied by x1 means 2 multiplied by minus 4. In the denominator we have m1 plus m2 means 3 plus 2 here. Now the second part for finding the value of y here means the ordinate. Again we will substitute the value m1 y2 plus m2 y1. m1 here is 3 multiplied by y2. y2 here is minus 5. Again we will add it with m2 y1. The value of m2 here is 2. It will be multiplied by y1. The value of y1 here is 6. Now in the denominator we have m1 plus m2 means 3 plus 2. Now we will just simply solve it here. So we are obtaining the value of P, means the coordinate which are dividing the line segment into two parts here, and we are finding these coordinates by using section formula. Okay. Now coming on to some more examples on this topic. Here we have been given that in what ratio does the point A6 divide the join of minus 4, 3 and 2, 8, and we have also to find the value of A here. Here it is given that in what ratio does the point, this point A6 is dividing the line segment in which ratio. We will see it here. We have to find the ratio in which the point A6, the coordinates of this point, is dividing in which ratio, this minus 4, 3 and 2, 8. We have here to find the ratio. The coordinate, the section for part is already given here. We have just to find the ratio in which the line segment is divided into two parts. Suppose we will let it as A, B, and the point which is creating the section here we will let it as P. We have to find the ratio in which the point P is dividing the line segment AB into two parts here. So we will denote it by x1 y1, x2 y2, and this point by x and y. Here we have just to find the ratio here. So the value of y is given here, that is 6. So we will directly use the formula here, that y is equal to m1 y2 plus m2 y1 by m1 plus m2. We have just to find the ratio here. The value of y means the ordinate of the coordinate P is given, that is 6. m1 is unknown to us. We will multiply it by y2. The value of y2 here is 8. Again we will add it with m2 multiplied by y1. The value of m2 there is unknown to us. We will multiply it with y1, that is 3 here. Again m1 plus m2. On cross multiplying, we will get 6m1 plus 6m2 is equal to 8m1 plus 3m2. So we are obtaining the ratio m1 is to m2 is equal to 3 by 2. The ratio which is dividing the line segment into two parts is 3 is to 2. Now on the basis of this note, we have to find the value of a there. We have to find the value of a here, that is the abscissa here. So we'll again use the formula x is equal to m1 x2 plus m2 x1 by m1 plus m2. The value of abscissa, that is x here, is a. Now we will substitute the value of m1 x2. We have obtained the value of m1 as 3 here. So 3 multiplied by x2. The value of x2 here is 2. Again m2 is multiplied by x1. The value of m2 here is 2. 2 multiplied by minus 4. Now m1 is added to m2 means 3 is added to 2. We will obtain it as 5a is equal to 6 minus 8. So 5a is equal to minus 2, a is equal to minus 2 by 5. So by using the ratio, we are finding the value of a here. Okay. Now coming on to the next topic on section formula. So the next topic in section and midpoint formula is points of trisection. Points of trisection. We have earlier read about bisecting. Bisecting means dividing into two equal parts. Bisecting means dividing into two equal parts. And trisecting or trisection means dividing into three equal parts. Suppose we are given here a line segment, and if we are substituting 2 points on it, and if they are creating three equal parts there, then we will say that these points are point of trisection. Means suppose here it is A and B, this point is P and Q. We will directly say that PA is equal to PQ is equal to QB. It means that on the line segment AB, if 2 points P and Q are substituted, they are creating equal parts there, and all the three parts are equal here. So points of trisection means 2 points lying on a line segment, and if they are creating equal parts there, that means these points are points of trisection there. So on the basis of points of trisection, we will see some example here. Here we are seeing an example on the basis of points of trisection. Here we have to show that the point A is a point of trisection of the line segment which is joining the points 2, 1 and 5 minus 8. And we have also to find the coordinates of the other point of trisection here. Suppose we are seeing it here that the line segment 2, 1 and 5 minus 8 is getting trisected by the point A or not. We will let this point as P, we will let this point as Q. We have to show that the point A is the point of trisection of the line segment joining these 2 points, that is P and Q here. Suppose we are letting here at let A and B be the point of trisection. We are letting here that A and B be the point of trisection of the line segment joining the points P and Q here. So PA will be equal to AB will be equal to PQ. We are assuming, we have to show that A is a point of trisection, and we are assuming that A and B be the point of trisection here. So PA will be equal to AB will be equal to BQ here. So we are arising here PA is to AQ will be equal to 1 is to 2. Now on the basis of this ratio, we will arise the coordinate of A. And if the coordinate of A will be 3 and minus 2, then we can say that A is a point of trisection here. So let's find the value of A by using this ratio. And we will find the value of A by using the section formula, that is m1 is multiplied by x2. So the value of m1 here is 1. 1 will be multiplied by x2. We will substitute the value here as x1 y1. It will be x2 y2, and we will substitute this as x and y here. So we are arising the value of A by using section formula. So m1 is multiplied by x2. So 1 is multiplied by x2. The value of x2 here is 5. Again, we will add it with m2 multiplied by x1. The value of m2 here is 2 multiplied by x1, that is 2 here. Now we will divide it by m1 plus m2 means 1 plus 2 here. This is giving us the value of abscissa means x. Now on the second part means y, that is the ordinate here. So m1 is multiplied by y2. The value of y2 here is minus 8. Now it is getting added to the second part, that is m2 is multiplied by y1 means 2 multiplied by 1. Now it is getting divided by m1 plus m2, that is 1 plus 2 here. Now we will solve it. So here we can see that we have obtained the value of A is equal to 3 and minus 2. That is the original value. So we can easily say that this ratio is giving us the value of A, that is equal to 3 and minus 2. So we can say that A is a point of trisection of the line segment joining P and Q here. And to the next part given here is that also find the coordinates of the other point of trisection. It means we have to find the coordinates of point B here. So we'll find the value of the coordinates of B here by using the ratio. Since A is the point of trisection, it means PA is equal to AB is equal to BQ here. So we will find the value of B here. We have shown that A is a point of trisection. A is a point of trisection. A is a point of trisection, that means PB is to BQ is equal to 2 is to 1. We are obtaining the ratio here since we have proved that A is a point of trisection. Now on the basis of this ratio and using the coordinates of these 2 points, we will arise the value of B here by using section formula. That is m1 is multiplied by x2 plus m2 x1 by m1 plus m2, that is the value of x means abscissa, and the next part, that is ordinate, m1 y2 plus m2 y1 by m1 plus m2. Now we will just simply substitute the value here, that is m1 is getting multiplied by x2. m1 here is 2, it is multiplied by x2, that is 5 here. Again m2 is multiplied by x1 means 1 is multiplied by 2 here, divided by m1 plus m2 means 2 plus 1. Now the second part, that is ordinate here, m1 is multiplied by y2. m1 here is 2, so 2 is multiplied by y2. y2 here is minus 8. Now it is getting added to m2 multiplied by y1. It means 1 is multiplied by 1 divided by m1 plus m2, that is 2 plus 1 here. So now we will solve it. So we are obtaining the coordinates of B as 4 and minus 5 here. So now coming on to the next topic.